Okay, so now we're going to talk about isomers. The first isomer is a structural isomer. These are isomers that have the same molecular formula, but their atoms are joined together differently. And then we have stereoisomers, the first of which we'll call conformational. These are the forms of the same molecule, but they have different conformations or arrangements because they can rotate about that sigma bond. And remember that a sigma bond is a single bond. Another type of isomer is a configurational isomer. These consist of both cis-trans, also EZ, and optical isomers. Remember, the EZ or the cis-trans can be alkenes or cyclic isomers. And to determine whether cyclic isomers are optical isomers, you would look for that plane of symmetry. You have cis and trans or EZ because there's no rotation. You're locked into that arrangement of the atoms in a 3D space because your structure is locked. Because remember that double bond with that pi bond, they can't rotate, and with a cyclic structure, they also cannot rotate about those single bonds. Optical isomers are called optical isomers because they're going to rotate plane polarized light. You should be familiar with how that works, right? It should be in your notes. Optical isomers are mirror images of each other, and they have what's known as a chiral carbon. That's a carbon that has 4 different groups attached to it. Optical isomers are made up of enantiomers. Remember, these are the mirror images. Each enantiomer will rotate plane polarized light in different directions but the same amount. If you're going to draw cyclic structures, please draw them in 3D, all right, so that you can tell whether they are cis or trans. Here we have a trans 1,2-dichlorocyclopropane. It's optically active because there is no plane of symmetry. So this enantiomer will rotate a plane polarized light in one direction. Its mirror image, I'm sorry, now I'm going to stop there. Okay, so let's look at enantiomers and mirror images. So here we can identify that this molecule has 4 different groups attached to the carbon, so that carbon is a chiral carbon. To actually illustrate that it has a mirror image, you need to draw it in 3D. When you draw it in 3D, make like a plane that's the mirror, and just kind of flip it so it would be its mirror image. That's the best way to show that these two are mirror images of each other.